The Drawworks is part of the rig's hoisting system. It's a heavy-duty transmission and braking system that winds up and pays out the drilling line. It's big because of the large hook loads and great depths we drill to today. In this program, we'll look at how the hoisting system works, the DC Drawworks, the AC Drawworks, Drawworks braking systems, and lubricating the Drawworks. A typical drill floor. The Drawworks is controlling movement of the drilling line. The line controls the lifting and lowering of the drill string. The drilling line starts at the supply reel. It then runs through the deadline anchor. From the deadline anchor, the line goes up to the top of the derrick, where a multiple pulley called the crown block is located. The pulleys in the crown block are called sheaves. The drilling line is threaded, or as they say on the rig, reeved over the sheaves. The line goes down the crown block to another set of sheaves called the traveling block. The line is reeved through one of the traveling block sheaves. It then goes back up to the crown block, where the line is reeved over a crown block sheave. Then it goes back down to the traveling block. You can see that the line is reeved several times between the traveling block sheaves and the crown block sheaves. Here, the crew strung 14 lines, but there could be more or less. More lines make the traveling block move slowly, but they give it the strength to lift very heavy loads. The last line strung over the crown block sheaves runs down to the Drawworks drum. This part of the line is the fast line, so called because it's the part of the line that moves the fastest. A wedge anchors the end of the fast line to the drum. The driller then takes several wraps of line onto the drum. Part of the drilling line that comes down from the crown block and to the deadline anchor is the deadline. It's called the deadline because, like anything that's dead, it doesn't move. The deadline anchor firmly holds the drilling line. It anchors it. As long as the line is clamped, the supply reel can't give up any more line. Here's the complete system. The line starts at the supply reel and goes to the deadline anchor. From there, the line goes to the crown block. The line is reeved several times between the crown block and the traveling block. Finally, the line goes down to the Drawworks, where it is attached to the drum with a wedge. With the drilling line completely strung up, when you take in the line with the Drawworks, the traveling block goes up. When you let the line out, the traveling block goes down. The driller lifts and lowers the load by taking in or letting out line from the Drawworks drum. The driller controls the speed the line goes onto the Drawworks drum by shifting gears in the Drawworks transmission. A Drawworks transmission is somewhat like a car's manual transmission. Going up a steep hill, you use a low gear that gives you more power but less speed. As the hill levels out, you shift into a higher gear, which gives you less power but more speed. The driller can do pretty much the same thing on the Drawworks. Shift to low and lift a heavy load slowly. Shift to high and lift a light load faster. The transmission in most Drawworks consists of several heavy-duty chains and sprockets. The transmission drives the Drawworks drum to take in drilling line. But how the transmission gets power varies. For example, Here's a schematic of an old-fashioned mechanical drive system. The engine's drive chains and sprockets, called a compound. The compound, in turn, drives the Drawworks transmission and other rig components. A few rigs still use a mechanical compound like this, but today, most rigs use diesel engines to drive. Not chains, but electrical generators. In this electric drive schematic, you can see that electricity from the generators goes through heavy-duty electric cables to DC motors on each rig component, including the Drawworks. On diesel-electric rigs, the driller can choose either high or low transmission speed by simply turning a switch. Say the rig's coming off bottom from 15,000 feet or 4,500 meters. The string weighs 375,000 pounds or 170,000 kilograms. So the driller puts the transmission in low speed. He needs power and a slow, steady pull to avoid swabbing the hole or getting the pipe stuck. The Drawworks drum also has two speeds, or drive ratios, obtained by means of drive clutches. One is the high drum clutch. When the driller engages the high drum clutch, the drum rotates at a relatively fast speed. The other is the low drum clutch. The driller uses the low drum clutch and low transmission speed to get the most pulling power and slowest speed. So, the selective transmission and dual clutch drive provides four speed-to-power ratios: low gear and low drum clutch, low gear and high drum clutch, high gear and low drum clutch, and high gear and high drum clutch. All Drawworks have a hook load versus clutch position chart. It shows the best clutch and transmission settings for the load to be pulled. But the driller's got to consider things like safe pulling speeds and the amount of power available from the engine room before changing gears. Setting a high transmission speed and high drum clutch might give you faster tripping speed, but if the Drawworks doesn't have enough input power from the engines, you could overload the generators. This warning light tells you if you're about to overload or black out the rig power plant. Keep an eye on this light when changing Drawworks speed. And if you know you've got some heavy drill string loads coming up, it's a good idea to let the mechanic know so he can put an extra generator online. If the low drum clutch fails, you can't lift pipe out of the hole. Repairing it is time-consuming.
Looks like my low clutch is slipping a little bit. I'm losing air pressure on it. I'm going to go ahead and change transmissions and go to my high clutch. Check to see if we got any air leaks.
Consequently, if the clutch fails while the drill string is in the open hole, you can't hoist the string and it can get stuck. To get around this problem, manufacturers install a special locking bolt. Sometimes there are two on the low drum clutch. You can install this bolt in the low drum clutch's spider and lock the clutch to the Drawworks drum. With the clutch locked, you can continue to trip the pipe and fix the clutch later. AC motors power the latest type of Drawworks, Active Heave Drawworks, or AHD for short. The driller controls it by selecting sophisticated high-technology electrical switchgear. Instead of a transmission, 6 powerful AC drive motors control the hoisting speed. The AHD provides motion compensation. As you see here, landing a BOP without AHD is tough, but landing it with AHD is easier. Understanding how to move the drilling line is good, but you've also got to stop it as well. So let's take a look at the braking systems. Drawworks have two kinds of brakes. One is a mechanical brake on the Drawworks drum. The other is the auxiliary brake, sometimes called the El Magco. The hook loads the Drawworks lift are heavy, in fact so heavy that the Drawworks requires two braking systems to stop them. Here's why. A heavy load has a lot of momentum. Like a huge locomotive, once it gets started, it's hard to stop. A heavy hook load is the same. Once started, it takes a lot of braking force to stop it. In fact, the mechanical brake alone cannot quickly bring a heavy load to a complete stop. But because the auxiliary brake absorbs most of the momentum, the mechanical brake works more efficiently. Thus, with the auxiliary brake helping, pressing down on the mechanical brake lever stops loads quickly and completely. In the mechanical drum brake, you can see the two brake flanges bolted on the drum. The brake bands wrap around them about 270 degrees, about 3/4 of the flange circumference. The bands hold brake blocks against the flanges. The brake blocks are pre-formed to match the flange's contour. Friction between the blocks and the flange provides the braking action. The brake flanges are hollow. A pump moves water through them to carry off heat created by friction. The blocks are similar to brake shoes or disc pads on your car. They're composed of fibers and copper wire. Resins or plastics bind everything together. The blocks have to be hard enough not to wear out too fast, but soft enough not to cut the drum flanges. And they have to absorb heat, but not burn. When the driller presses on the brake lever, he activates this equalizing bar at the front of the drum. The bar puts equal tension on both brake bands as it tightens them against the flanges. Because the brake handle is a lever, 150 pounds or 70 kilograms of pressure on it creates about 2,500 pounds or nearly 1,200 kilograms of tension on the brake bands. That's enough to slow down and stop the drum. Regularly inspect the brake blocks, flanges, and bands for wear. If you notice that one side is more worn than the other, the equalizer needs adjusting. To adjust the equalizer, turn the bottom nut on both sides until the bar sits exactly 1/8 of an inch, or 3 millimeters, above each of the pads. It's best to use a feeler gauge to make the adjustment. Once you have adjusted the bar, tighten down the top nuts. Then lock everything in place with the jam nuts. The brake handle provides the most leverage when it's at about 45 degrees. To keep it in this position, adjust the nuts on both sides of the handle. While you're there, make sure no pins are missing and check for signs of damage. Check the brake band's kickback rollers each time you adjust the brakes. Adjust these rollers to give about 1/8 of an inch, or 3 millimeters, clearance from the brake bands. You can use an 1/8 inch welding rod to gauge the clearance. The brake needs to float. If the kickback bands are bent, replace them. Don't forget proper tension on the brake band's supporting springs. They support the upper portion of the band when the brakes are disengaged. The springs keep the brake bands from dragging on the rims. Dragging bands kick the brake handle up when the driller engages the clutch. So, if necessary, adjust the tension. Some Drawworks have disc brakes. Disc brakes are generally more powerful and more efficient than mechanical band brakes. They're also quieter. They don't squawk like regular brakes. Drawworks with disc brakes have 4 to 6 hydraulically operated calipers on both ends of the drum. The calipers close against a hard-faced rim bolted onto the brake flanges. As with brake bands, a pump moves water through a chamber inside the rim to carry away the heat. The manufacturer usually installs 2 sets of brake calipers. The driller activates the service calipers by pressure on the brake handle. Hydraulic pressure against a strong spring normally holds these special calipers open. But if the hydraulic or electrical systems fail, the springs apply braking force to the rims. Besides providing emergency braking power, the driller can use these calipers as a parking brake when the Drawworks is shut down for maintenance. The second, or auxiliary brake system, is an eddy current brake, often called the Almagco, a brand name. An iron rotor or extension on the drum shaft rotates inside two magnetic assemblies. An air gap of only 4/1000ths of an inch, 1/10 of a millimeter, separates the rotor from the magnets. An electric current applied to the magnets sets up a magnetic field. This magnetic field creates another magnetic field in the rotor. When the drum turns, the fields in the rotor and the magnets oppose each other and slow the rotation. On a much smaller scale, it's like two magnets repelling each other when you try to put the same poles together. Inside the Almagco brake, the same opposing magnetic forces, but much stronger, of course, slow the Drawworks drum. A water cooling system carries off the heat the mechanical and the Almagco brakes create. Water circulates through the mechanical brake flanges and around the Almagco to cool them. If the water isn't circulating, the brakes can burn out or slip, and you won't be able to stop the load before the blocks hit the floor or the crown. So, periodically, check the water's flow rate. All you need is a stopwatch and a container with a known capacity, like 2 gallons or 8 liters. Simple arithmetic gives you the flow in gallons or liters per minute. When handling heavy loads, the manual says at least 65 gallons or 250 liters of water per minute should circulate through the Drawworks drum flanges. The Almagco needs as much as 150 gallons or 550 liters per minute. If the flow rate's not adequate, then shut down and notify the mechanic or your supervisor. This is a trap in the brake cooling system. The screen prevents any foreign material from entering the system, and it can get clogged up. About 50 to 75 psi, or 350 to 500 kilopascals of water pressure, is needed to circulate the water through the drum flanges. And depending on the piping, it may take even more pressure to circulate the water through the Almagco brake. If you notice a drop in water pressure, the problem could be here. Also, be sure the water pump packing is lubricated and the bearings are properly greased. To keep the Drawworks running smoothly, you need to lubricate certain points on a regular basis, like daily and weekly. Because you seldom find any two Drawworks that are alike, be sure to refer to the manufacturer's lube chart for the one on your rig. However, here are some general points to keep in mind. Before lubricating anything, lock out and tag the Drawworks power switch. Locking out keeps it from being accidentally started. Do not lubricate the Drawworks when it is being used. If you get caught in the transmission, well, let's just say that the blood and body parts are not proper lubrication. Most Drawworks have a lubrication manifold like this. Refer to the manufacturer's lube chart to determine how often you should lube these points. Of course, several other lube points also exist. Again, refer to the manufacturer's manual for where and how often you lube your Drawworks. And remember, the Almagco brake also requires lubrication. Further, be sure to check the oil level. If it needs oil, find out what the correct kind is, then add it until it's to the right level. At the driller's position, grease the main brake lever. Be careful not to overgrease anything. Overgreasing can blow grease seals, which causes bearings to overheat and fail. When you're through greasing the Drawworks, inform the driller and turn it back on. Another important factor in keeping the Drawworks running smoothly is the oil lubrication system. An electric pump moves oil through the system. First, lock out and tag the pump motor. Then, check the motor's operation. Finally, turn the pump back on. The pump sprays oil through nozzles inside the Drawworks. The oil spray lubes the moving parts. Check the spray at least once every 6 months. Make sure the nozzles are not blocked. And finally, check the oil reservoir with the dipstick periodically when the Drawworks is running. If it needs topping up, make sure you use the right grade of oil. The Drawworks is a vital piece of equipment. We can't drill without it. Fortunately, it's a rugged and heavy-duty machine, built to take a lot of hard use. But like any machine, if you fail to service it, it will surely break down. So take care of the Drawworks, and it'll pay you back with years of trouble-free operation.